Hey everybody, just want to share a valuable lesson that I learned. So I was charging this unit, it was a little bit low, and I was charging this unit. This is a heat pump in heating mode. And I was looking at measure quick, and I was looking at things like approach temperature, delta T, the typical things that you do when you're charging a heat pump in heating mode. Well, as I kept charging it, my numbers started getting worse. My approach went back to zero, and I was just not happy with it. My delta T went down to like 12 degrees, which we know is not good. We want to see something at least 16, 17 degrees even on a cold day. It's 35 degrees out here. And so I decided to take some of that refrigerant out. And what I learned, as you'll see from the next slides, is that when you overcharge a system, your approach can go back down to zero. And I'll explain why. So as a reminder, approach temperature is the difference between your return air temperature and your liquid line temperature when you're talking about a heat pump in heating mode. Now in cooling mode, you would measure your liquid outside and you would take your outdoor temperature. But in heating mode, because your indoor coil becomes your condenser, approach temperature is measured by subtracting your liquid temperature coming out of your indoor coil from your return air temperature. Typical approach temperature is going to be somewhere between 3 and 17 degrees typically in heating mode. But you should always have some kind of approach temperature. Your liquid line should always be a few degrees warmer than your return air, because that means you've got a little bit of heat left over as that refrigerant leaves the indoor coil. If your heat pump is undercharged, then that means that your approach temperature is going to be closer to zero, and that's because you're just not making a warm enough indoor coil, and that heat that's generated in that indoor coil is being just used up as quick as it can get in there. So your liquid line temperature, it ends up being the same temperature as your return temperature, because we just don't have enough heat in that indoor coil. But when it's overcharged, think about what happens. This liquid refrigerant, this warm liquid refrigerant, comes out of our indoor coil and it eventually sits there waiting to be used by the outdoor TXV. Well, if you're overcharged, you've got all this liquid that's stacking up in your indoor coil and it's not being used. So it's just sitting there getting cooled down and cooled down and cooled down by your return air. So your approach will also be low if you're overcharged. This is what I found when I stopped putting refrigerant into the system, because I realized I wasn't making it any better. As you can see, my high side pressure is way too high and my approach is zero. That's not normal. If you walk up to a unit and it's running like this, you can't leave it like that. So I started taking refrigerant back out of the system. In fact, I took more refrigerant out than I had originally put in, meaning that I had slightly overcharged it back in the summer when I worked on it last. And this is the result. Notice how everything improved. Not only did my high side pressure come down, which means my compressor is trying less hard to do the same amount of work, but my approach went up. And guess what? My temperature drop across my indoor coil got a lot better with less refrigerant in it. So the best thing to do when you're charging a heat pump in heating mode is to go very slow and wait. Charge maybe a quarter pound at a time. Watch your readings. If you see your approach temperature go up and then come back down, that means you've probably added too much refrigerant for that system. The other thing I want to point out is sensor placement. Make sure when you're measuring approach temperature in heating mode that your temperature, your liquid line temperature, is being sensed when it comes out of the indoor coil. That's because if you've got a long line set that goes through an unconditioned space, that liquid will start losing temperature, so dropping temperature, because it's cold in the surrounding area around it. And so if you're measuring it at the outdoor unit, you're going to be a few degrees off, and just a few degrees could be the difference between you thinking a unit is undercharged or properly charged. The other thing is your return air sensor. Now, a lot of people want to measure their return air sensor at the grill, and that's fine, but again, when you're going through a long duct run through an unconditioned space, and let's say that duct isn't insulated very well, this is R4 duct, it's kind of old, then your return air is going to cool off. And so you're not really seeing what the refrigerant sees when you measure your return air temperature at the indoor grill. It could be 5 or 6 degrees warmer up there than it is where it actually hits your coil. So when we're taking our temperature readings, if you're worried about delivered capacity, then yeah, take it at your grills. But when we're charging equipment, I strongly recommend that you take your return and supply temperature coming off the equipment. Now we need to be very careful that we're not too close to the indoor coil where we could be measuring radiant heat. I've played around with this a lot. I really don't see that very often. If you're taking it at a furnace, and yeah, don't be too close to the heat exchanger, because that heat exchanger is like 4,000 degrees. But when you're working on a heat pump, you're measuring supply air temperature. I know a lot of people say don't take it too close to the unit, you'll be measuring radiant temperature. I've taken it all over the place. The biggest difference I see though is when you got ducts that are poorly insulated running through an unconditioned space. Taking them too far away from the unit throws you off. As far as outdoor unit probe placement, when you're working on like a York, or in this case an American Standard Train, they let you take your suction line temperature. They give you ready access to it because it's right here on the side. They're readily accessible, so you can clamp your temperature probe on there and get your reading. When you're working on Carriers and their brand equipment, Goodman's, other brands where the compressor suction line is really not accessible, I get it. It's very inconvenient to try to get that temperature. Maybe if you're doing a non-invasive test, you can get away with not doing it as long as you're measuring other things like temperature rise, approach temperature. But when you're looking at the charge of the unit, you're specifically trying to fix a problem, you really need to give MeasureQuick all the information that it's asking for. And so how do you get suction line temperature? The easiest way to do it is just pop the screws off your condenser fan and just reach down in there and clamp your probe onto the true suction of the compressor. And just don't forget them when you leave. So it's really not that hard. You don't have to take the whole top of the unit off. A lot of these units, you can just take a few screws off and you can get the compressor or the condenser fan out of the way and take your readings. So do that when you're messing with the charge, when you're diagnosing complicated problems. It's well worth the time to do it. But in the end, don't forget to get your probe back. Okay, so truth be told, I was actually the one that overcharged this unit, and it happened back in cooling mode. I made a repair, and I must have just put about a half a pound too much in there. MeasureQuick said it was okay, but it wasn't. And so I overcharged it slightly, and it didn't really affect it in cooling mode, but when I came back on a cold day to check it in heating mode, I saw it was not performing very well. It had a very low delta T, had a very low approach, only about 0 degrees of approach. So I thought, maybe I didn't get enough refrigerant in this thing when I charged it back in the summer. So I added about 2 pounds of refrigerant. Guess what? I ended up taking back out 2.5. Yes, I had overcharged the system by about half a pound back in the summer, and that caused some performance issues. So the lesson here is a lesson that I keep apparently having to learn the hard way over and over again. When you charge a unit, charge slow. Try to weigh the charge back in, and if you're checking the unit in heating mode, don't get fooled by a low approach. It doesn't necessarily mean that the unit is undercharged. It could be overcharged.